Okay, so we are in Statistical Rethinking, second edition, chapter 8, and we're on the hard questions, and so we're on 8H3. So there's going to be some code here, and so make sure that you have installed and loaded the Rethinking package. So I'm in Colab right now, and for reasons that I don't understand, my installation and loading is failing every time. So I had to do this entire thing instead in R, or in R Markdown here, which looks like this. And I made a HTML document out of what I ran on my own machine here. So I'll be going off of this, but the code is all here, but in the Colab sheet, so you can look at the code and it works, and you can walk through it and put it onto your own machine where you hopefully have Rethinking installed. Okay, so what we are doing is we are considering a data set that was used earlier in the chapter called rugged, and in the analysis that we were doing there, or that the book was doing there, is we were trying to determine the effect of ruggedness on GDP of a company or of a country. And there was this idea that maybe countries inside versus outside of continental Africa may have a different relationship, or the relationship between GDP and ruggedness of their terrain may differ inside and outside of Africa. Okay, so that's the idea. We are going to go through parts A and B here. So we're going to focus on M8.5 from the chapter. Now this is actually a typo. I believe that this should be M8.3 in the chapter, but for whatever reason, just a typo in the textbook. So it should be model M8.3. So we're going to use pointwise penalties from WAIC and PSIS to measure the relative influence of each country. And then we're asked, I don't know how to say this country, Seychelles, influencing the results. Are there other nations that are relatively influential? And if so, can you explain why? Okay. And then we're also going to modify that regression, but we'll get to part B when we come to it. Okay, so, so the first thing we need to do is to load the data and then do some manipulations to it like we did earlier in the chapter, which is what we're doing here with this code. And then we get the model up and going. So again, it's M8.3, I believe. M8.5 is dealing with a completely different data set. So, so let's look at the penalties, the WAIC and the PSIS penalties. So here I have the WAIC pointwise penalties, as well as the PSIS penalties. And then here I'm just merging them together with this merge command. Okay, so I merge the PSIS data frame with the WAIC data frame by country. And then I'm organizing the rows. According to penalties from greatest to least. Okay, so this is what we have right here, right? So we have the country, the K value from PSIS, and the WAIC value. Now, if you're running this on your own machine, you should probably run this a few times because you'll get different values for PSIS and WAIC each time. And the question implies that Seychelles will always be the value, or the country with the greatest penalty value. But I found that that's not always the case. Sometimes it's not, and sometimes it's kind of middling actually. But when you run that code several times, Seychelles usually comes out to be the top value. So you may need to run it a few times. Okay, so this is the whole data frame here. Let's scroll through here. So is Seychelles influential? Okay, so here I guess it kind of depends on what we mean by influential. It seems to be the most influential, and in this case, the K value is well above 0.5, verging on 0.7. Where 0.7 is kind of this soft threshold that gets used for PSIS values to say like how well is it overly influential, I guess maybe is one way to think about it. But if you run this several times, it's not always this high. Sometimes it's just 0.5 or a little over or under 0.5. So it kind of depends on the run. Unfortunately, I think you have to run it maybe several times to get a good sense of it. So is it influential? Yeah, I guess so. I guess it is. It's among the top spots, and its value is kind of starting to exceed this kind of soft threshold. But I think we can maybe get a better sense of it, of how influential it is in a few ways. So one thing we can do is we can run the model again, but we're just going to omit Seychelles, right? So I have the data frame here, and I'm just omitting that particular country. Okay. So now I run the same model, but just on this new data here. Okay. And so one thing we could do is we could compare the posterior distributions. So this is the old posterior, and this is the posterior without Seychelles in there. Okay, but it's not. It's hard to understand what the implications might be here. So so the next thing that we could do, or maybe the better thing to do in this situation, is to run counterfactual simulations with the two models to see which one is doing better. Okay. Right, so we could do that, and we're going to do that here, but we're just going to try to predict Seychelles between the two models, okay, to see how well they do. So I'm going to extract samples from both models, the one with Seychelles in the data and one without Seychelles in the data, okay, and then I'm going to use the posterior draws from both models to try to predict Seychelles, okay? And so that's what's going here with the two models, okay? Now, you wouldn't normally do this, like you wouldn't normally run this particular bit of code, the highlighted bit, because the data was already, this model was trained on Seychelles, and so to try to predict Seychelles, it's a little weird. Because the thing we're trying to predict is already in the data set, okay? But we're just doing it here, I guess, just because it's interesting. Okay. So anyway, so I've predicted Seychelles. Okay. So post and post no say have 1,000 or 10,000 samples for each of the parameters, and so I'm just combining the parameters according to the linear model that is in our the linear model that we've regressed on. I'm according to this. Okay. And then I'm plotting it. So the no-say model, the no-Seychelles model, is this red curve, and then the model that has been trained on Seychelles is this curve right here, and the solid line is the actual value, the empirical value found for Seychelles in the data for the log standardized GDP. Okay, and so neither one is doing great. Okay, in fact, visually the tails don't even extend all, they don't even surpass the actual value. So that's kind of interesting. So that does suggest that maybe Seychelles isn't, it's a little bit of a weird bit of data, or that given our model, it's a weird piece of data. It really maybe indicates that our model is insufficient. But okay. So, but I thought that we should also maybe do this with a country that is not highly influential. So now I'm looking at the bottom 100 countries, or the least penalized countries, and then I just scrolled until I found one that I knew was in Africa, and it would happen to be Kenya. I'm not sure, Kenya is somewhere in here, but so I'm doing the same thing with Kenya. So I'm predicting Kenya, and trying to look at how that gets predicted, right? So now, so let's see here. So red is the no-say model, okay, and the say model with Seychelles in the data set is the blue dotted line, okay. And now it seems, so now this might be more evidence just in this particular case. Like we'd want to do this with a lot of countries, but in this particular case, the fact that red, the no-say model, is doing better is again suggestive of maybe one of two things. One, that our model is not doing good, right? Is not a good suit for the data, or that Seychelles is kind of a weird data point, at least given the model, right? Because the model actually does worse when we give it more data, at least in terms of predicting, right? So anyway, Okay, so are other countries influential? Well, sure, and by the same criteria. So if we went, sorry for all the scrolling, but if we went back up to our penalty table, well, yeah, Lesotho might be, and Switzerland might be. Okay, so it depends on how you want to define influential. But in this particular draw, no other country is really in the same ballpark as Seychelles. That's not to say, again, on different runs of the PSIS command or whatever, it wouldn't seem that it was. So anyway. Okay, where were we? Okay, so we want to get to part B. Okay, we're past this. Okay, so now we want to adjust the regression. So instead of log GDP being a normal distribution, we are going to make it a t distribution with 2 degrees of freedom. Okay, so t distributions are broader than normal distributions generally, especially with few degrees of freedom like 2. Okay, so we're just going to run this, and we're going and we're asked, does this change the results? Okay, so I run this, and so we can start by just comparing the posteriors, okay, again from the first model, and now the same model, but now we have a t distribution instead of a normal distribution. But again, it's not, we can compare these, but the implications really, it's hard to make sense of any of the implications. So but we're asked, does it change the results? Well, it depends on what results. And I don't think that's really made explicit in the question, but in the chapter, what we're kind of after is we're trying to assess, let me go back up to a linear model. We're trying to assess the effect of ruggedness, or standardized ruggedness, on standardized log GDP. Okay, and we're hypothesizing that maybe countries inside of Africa versus outside of Africa, which are encoded with this CID variable, that this relationship differs for countries inside versus outside of Africa. And so I think that's what we'll focus on. We'll focus on the difference in this B parameter for countries inside and outside of Africa. Okay, so the way that this was encoded up top, and you can go and look, but countries outside of Africa were given an index of 2, and inside of Africa were given 1. Okay, so I'm just extracting samples again, and then I'm just pulling out, first with post, which was the normal model, and then post-t, which is for the t-based model, the t-distribution model. I'm just subtracting the beta coefficient estimated for countries outside of Africa versus inside of Africa. Okay, and then I'm just displaying the posterior density of those 2 models. Okay, so when we shift to a t-distribution, okay, the t-distribution. The t-distribution is the solid line in this case. Okay, so when we go from a normal distribution to a t-distribution, we do see that the posterior shifts. Okay, so there is some effect apparently of using a t-distribution to estimate things. Okay, another thing that we could do is we could compare the 2 models, the M83 with a normal distribution versus a t-distribution. And see which model does better. Okay, and so when we run this with both WAIC and PSIS, so we see that in both cases, the normal model actually does better than the t-distribution, right? The t-distribution is heavily penalized. Okay, so take that for what you will. I think that probably has a lot to do with how we defined the GDP variable. We took the log and then standardized it, and that probably is much closer approximated by a normal distribution than a t-distribution. But anyway, that's neither here nor there for this question. Okay, so sorry about the inconvenience on the Colab. Again, I hope that this isn't a persistent problem, but all of this code works. In fact, it's identical to what you've just seen. Okay, thank you.